Hello, my name is Bhaskar Chattaraj, and this is my final project presentation in deep learning course at Stanford. It's confidence to interpretation. Now, what is that? Now, deep learning has been extremely successful in making very accurate prediction, especially in the fields of computer vision and natural language processing. And it almost looks magical. And because of the complexity of the models, there's a black box nature to the solutions. So you have to convince the decision makers that the predictions actually make sense. And you have to do it in a very nice way. And there are two frameworks which we'll discuss in this presentation: LIME, which is the locally interpretable model agnostic explanations, and Shapley additive explanations. Now, what are they? In LIME, what they do is they take, so this is a very complicated solution, a complex model. What you do is you take samples around it, build a simple interpretable model around it, and build a local model to explain the predictions. In SHAP is based on sort of Shapley additive explanations. So what we do is, take an example of a picture. This is a picture of a dog and it has some predictions. We remove the face and look at what the predictions and remove different parts of it. So you look at all the features, add and subtract them, and kind of find out what contributes most towards the prediction. We will be using the following four data scenarios in my project report: synthetic, tabular data, tabular image data, and text data. Remember, these explanations must be interpretable, faithful, and model agnostic. So, but in this presentation, we'll discuss only the last two cases. We used VGG16, which is a kind of well-known convolutional neural network model, and I took the picture of mine with my dog and said, what's the prediction? And the prediction was, the first prediction was a Bouvier-Leflandres, and if you see the image below, it looks very similar to the dog. Now, what does LIME do? LIME does superpixels. It takes a collection of pixels very close by, and the dark blue color actually explains the predictions, which is pretty good. What does SHAP do? What SHAP does is it breaks the picture into 50 sort of slices and then adds and subtracts, removes the slice and then looks at the prediction. And the green areas show you what's the kind of the higher, which creates the higher probability of this prediction. And so you can see the dog really stands out in all these predictions and my hand does not. Next, we looked at scikit-learn 20 news groups data and kind of data analysis on that. And what we found out is, one, we did a discrimination between guns versus politics, and the guns prediction looked pretty good in LIME. Whereas when you did atheism versus Christianity, what you found out was that email kind of entered the picture, which was kind of a data leakage and should be removed from the features. So in short, these methods are very important in building trust in these models, but they are at a stage where much more development is needed. And they can be used in checking results and helping at the end of the whole modeling process. Thanks for listening to me, and please read my report for a more complete description. Thank you. Bye.